Welcome to another Cloudonaut Plus video. My name is Michael, and today I'm going to talk a little bit about a new feature that was actually released over a year ago, but it became recently a topic again because AWS made some changes, and I'm going to talk about the Instance Metadata Service or IMDSv2. So before we dive into the topic, the question is, okay, why actually should you care? So what is the Instance Metadata Service version 2 and why is it important? And the big benefit of using version 2 of the Instance Metadata Service is that it improves your EC2 security. At least that's what AWS tells us. So what I'm going to do here is I will explain what it is, I will explain when it helps you, and I also show you a little bit how you can set it up and also what the pitfalls are when you use it. So in the end, you will actually understand if that is actually an improvement for you or not. And the reason why I was confronted with this topic once again is that AWS now recommends enabling IMDS version 2 in their security best practices. So this change was made, I think, a couple of weeks before, which caused like many of our clients to reach out to us and ask us about what they should do now, how we can transition, and what are the pitfalls. And basically this video, in this video, I will share all of those learnings with you that we made over the last couple of months when transitioning to IMDS version 2. So let's get started. There will be a couple of slides in the beginning to kind of introduce all the concepts. And then we, as usual, dive into a demo, and I will show you how this works. And also I will show you a common pitfall when working with Docker. So the Instance Metadata Service is by default accessible only from within the instance itself. So that's the default configuration. And therefore it is not in any way protected with authentication. So you don't need any access credentials to make a call to the Instance Metadata Service from within an EC2 instance. So it's possible not only by the root user, every Linux user can do that. You don't need any IAM credentials. So it is always accessible, and there is no authentication or any cryptographic stuff going on in the background. And the cool thing about Instance Metadata Service is it provides all kinds of useful information, but it also provides sensitive information about your instance. And the sensitive part is where it gets a little bit tricky when someone gets access to your Instance Metadata Service from the outside of your EC2 instance. Well, that's actually what happened. So there was a breach because someone misconfigured an EC2 instance and they exposed the Instance Metadata Service to the outside world, and an attacker was able to get access to credentials because of that. And that's kind of the reason why we have IMDS version 2 now. So before we look at the new version, we'll look into how it worked before in version 1. And there's no reason to worry. Version 1 is still there, so there's no breaking change. So everything will continue to work as before, but you can now transition to version 2. So a common way or common information that you can get from the Instance Metadata Service was and is the instance ID of the instance. So that's very useful. So I used this in a couple of scripts to get information about the instance itself when it started in the user data, for example. So with an HTTP request like this to the IP address 169.254.169.254, you can reach the metadata service and ask all kinds of questions, and you, for example, here get back your instance ID. As you can see, there is no authentication, no nothing in this request. It's just a plain HTTP request to the metadata service. The problem is that you can also ask the Instance Metadata Service to retrieve temporary credentials for the IAM role that is attached to this instance via the instance profile. And as you can see, the output that you get is actually your AWS credentials. So you get back an access key, and with those credentials, you can make API requests to AWS also from without your EC2 instance. So if you kind of copy and paste those values onto your local machine, you can then make calls like in the name of the EC2 instance. And that's actually where it gets problematic, because this was how the attacker got access to the infrastructure of the AWS customer that I told you before. So the customer was called Capital One, by the way. So that was a very famous data breach in the recent year. So, okay, let's go one step back and understand why this security credential thing is such a big problem. So how does actually the instance profile works and how is everything wired together? So imagine we have an EC2 instance and we want to make a call to the AWS API. So for example, use the AWS CLI to do that. Before the CLI makes the call to the API, it makes another call that you don't see. And this is a call to the instance metadata service. And you can see the request that it makes is it gets temporary credentials. And this is done because the instance metadata service actually reach out to the security token service and assumes a role for you, and you get back those temporary credentials. And the CLI caches those temporary credentials and then makes the original API call. So this is what goes on behind the scenes. So you don't see that. It's the same for the SDKs. So if you run a CLI or an SDK on an EC2 instance, that's the magic that goes on behind the scenes. Okay, so what actually changed with IMDSv2? First, it is now a session-based protocol. This means before you can make a query to the metadata service, you need to start a session. And the session is started with a put request to a specific endpoint. And within that put request, you can define how long the session will be in seconds. And you get back a token. And this token is then passed into all the subsequent queries to the metadata service as a header value. So why is this improving security? There are two reasons. I think the more obvious one and the one that might help you more is it makes server-side request forgery much harder. So what does this mean? Imagine you run a software on your EC2 instance and for some reason it is possible for an attacker to send a malicious request to this server, and then the server makes an HTTP request and the attacker can kind of control this value because, for example, there's broken input validation, things like this. So an attacker can make the server doing a request to a resource, and this way the attacker could get access to the metadata service. But now it's not one request that you have to do, it's two requests that you have to make. And you also have to get back the value, and you have to pass this value as a header value, which is much less likely to work because, I mean, there need to be lots of problems with the application if this attack actually would work. But it's not completely reducing this or kind of not completely avoiding the problem, but it makes it much harder. The other one is that, and this was actually the case for the Capital One breach, is that they used a so-called open web application firewall, which is kind of completely kind of crazy because the web application firewall actually is a software piece that you run to increase security. But in this case, it actually did the exact same, the exact opposite. So it worsened the situation. An open web application firewall exposes everything to the outside world that runs on the instance, including the instance metadata service. And if you are lucky, your open web application firewall does not by default also proxy the put request through everything behind it. So that's a very, very weak security mechanism in my perspective, but if you're lucky, it helps you. But I think the server-side request forgery thing is more relevant here. Okay, what else is different in instance metadata version 2? If you make such a put request to start a session, AWS looks into the headers, and if there is an X forward 4 header, they will not return a session. And this very likely is because you accidentally exposed the instance metadata service via a reverse proxy to the outside world. Again, this kind of a weak security mechanism, only if this header is present it works, but it's better than nothing. And last but not least, the response that comes back from this session endpoint comes with a network packet where the TTL is set to 1. So TTL basically means that there's only one hop possible for this packet and then it will be dropped. So it can only be received by your EC2 instance. You cannot this packet cannot traverse any longer in the network. And this can help you with level 3 or layer 3, for example, firewalls, all kinds of things that kind of make some changes to your network and to network packets that travel through the system. And I was running into a problem with that feature because, for example, if you use Docker with an overlay network, then this actually becomes relevant, because then there will be an additional hop before the packet is received in your container. But I will talk about this in a couple of minutes in more detail. So those are the changes. So it's now session-based. It makes it harder to for reverse proxies to expose the session endpoint, and it also makes it harder to accidentally forward packets with layer 3 firewalls and stuff like this. So it's actually a good thing. So how does it look like? So what's the how does the API look like? And you have to make 2 requests now. And first we start the session, and you start the session with a put request to the /API/token endpoint of the instance metadata service. And in the header, you can also define the TTL of that token. So in my example, it's 6 seconds, but you can have like much longer lifetimes for a token. And what you get back is a string, that's the token. And I read this here like in a bash, I put it into the token variable. And now I make a query to the metadata service. Again, I'm asking it to retrieve the instance ID. And what I have to add now is that I send an additional header, the x-AWS EC2 metadata token header, and there I include the value that I got from the previous request. And then again, I get back the value. So that's how it works. And you can make as many requests as you wish with that session token. It works as until it expires. So that's the session-based approach here. Okay, now let's look into the reverse proxy demo. So I will show you how this feature helps you to make sure that you cannot accidentally expose the instance metadata service anymore to the outside world. On this EC2 instance, I have installed Nginx, and I will show you the configuration of this Nginx. And what we can see here is that every time a request arrives at a /latest/, this rule kicks in, and Nginx forwards to 169.254.169.254. So that's the metadata service IP address. And I also ensure that I add the xforward for a header. And the problem here is kind of obvious. This header is not added automatically by Nginx. So if you forget that line, the whole security mechanism will not kick in, because it only works if the xforward for header is present. So, but okay, fine enough. We will see, and we will remove it later and then make sure or demo that it's actually not such a good mechanism. But that's the preparation that we need. And Nginx is also running here already. So what I'm going to do now is I make a request to the instance metadata service version 1. So this is not the session-based approach. I get back the answer. So I get back the instance ID. So this is working in the old version 1 as well. So this instance is configured to work with both versions. Okay, but now I make the same request using the Nginx configuration. So I not send it to 169.254 and 169.254 directly, but now I send this request to localhost. This is where Nginx is running. And you can see I get the exact same response, because this protection only works for the session API. It does not work for all the other requests that I can make. It only works for the request where I perform the put request on this token endpoint. All the other endpoints are not affected by this new change. So let me try to get such a token. And I have prepared a request here. So that's sending a put request to the /API token service. And I define that the TTL of that thing is pretty long. So what do I get back here is, again, a token. So that's working fine. Now I make the same request, but this time I'm not talking directly to the instance metadata service. Now I talk to this over the Nginx proxy. As you can see, the host name is now localhost. Okay, as expected, this is not working. We now get back a 403 and we don't get any token back. So that's the protection that kicks in here. Okay, so let's see that this actually works. I change the configuration and I remove the proxy header thing here. And Nginx restart, make sure that this configuration actually applies. And now I run the exact same request again. So I send the request to localhost to the Nginx. And as you can see now it works. So that's kind of bad. I get a token back through the Nginx proxy. So that's not ideal, but that's what I said. That's because of the missing x4 header. So kind of bad luck here. So let's continue with a problem I was running into when I used Docker. So let's clear the screen here, and I'm going to run a Docker container now in a way that might be a little bit unusual, but this is the way how it actually works. So I run a Docker container using the host network, so not the Docker overlay network. No, this is using the network of the host. And I let me install the AWS CLI here to make things a little bit easier to understand. And I'm going to make a request now to the AWS API, but from within the Docker container. It still reaches out to the instance metadata service of the EC2 instance that runs this container. So I just list all the S3 buckets. And this works. And this is what I expected how it always works when using Docker. But the thing here to understand is that this really only works if you use network type host. So let me kill that container. And I start a new container, and this time I don't specify what kind of network type I use. And the default in Docker is that it uses the overlay network, the Docker network. So I start again this container. I have to install AWS CLI here again. But the surprise now is that if I make a call to the AWS API, things are not working anymore. And this is now because of this hop limit of 1 that is set. It's not working, and it's pretty hard to figure out why it's not working. Because as you can see from the error message, it doesn't really show you that it's related to the hop limit. It's just some random kind of error that, unable to locate credentials. So I used an SDK, the Java SDK, when I was running into this problem. And the error message there actually is even worse. So it is completely, I would say it's more or less impossible to figure out the root cause by looking at the error message. It's the same here. So what is needed to make this work is that we configure this instance now to use a hop limit of 2. And I do this using the CLI. I'm going to show you the command here. 1 second. Okay, so, you reach out to the EC2 service, and the operation that we perform is called modify instance metadata options. You have to specify the instance ID, and then you can configure, for example, the put response hop limit, and I set this to 2 now. And I also say that HTTP tokens are required, which means that IMDSv2 is the only available option. I disable version 1 basically. So I was running this command in the background because this machine doesn't have permissions to change its own metadata options, right? That wouldn't be very, very clever. So let me run the command again. Now we have the hop limit of 2. And as you can see, it works again. So that's a pitfall, I would say. And I was running into it, and it took me 2 hours to figure out what the problem actually is. If you run Docker workloads on EC2s, definitely test if everything is working again. You might have to increase the hop limit if you use the default network type of Docker. So that's something you have to watch out for. I already showed you that I configured the hop limit to allow for 2 hops. So what are actually the configuration options? First, you can disable IMDS completely. So you can kind of turn it off. This will cause lots of problems because then the instance profile magic with the CLI and SDKs does not work anymore. So I'm not sure if that's really a good option. That's only an option if you run workloads that basically only operate on the VPC layer. As soon as you make an API call to AWS, that option kind of is not an option anymore. The option that makes sense is that you turn on IMDSv2 only. So you basically configure it that only IMDSv2 is supported anymore. This means that only requests with this token header are allowed. So that's kind of how you should, what you should do if you want to be compliant with this new best practice from AWS that you should use IMDSv2. And the other thing that you can configure, and that's what I did, you can you can define the put response hop limit. So for the packet that contains the session. So I checked out how this works for you. I mean, it works in the CLI, okay? But how does CloudFormation coverage look like? If you use launch templates, you are fine. You can just configure everything there. Recently, it also is now supported with launch configurations. So what I had to do, I have to migrate everything from launch configs to launch templates because it was not configured in launch configurations at this time. But I checked this again and now it's there. So that's fine. I could have saved lots of time if that support was be there from the beginning. One thing to watch out is that the only way to configure it on a single EC2 instance in CloudFormation is that you switch to launch templates. And if you do that, it will replace the instance. So that's kind of a, I don't know, not the super ideal solution. So if you have an EC2 instance that you would like to keep, then I don't know, you have to do something else, maybe a custom resource. Or wait a little bit until AWS fixes that. And I mean, this feature is out for more than 1 year. So you might have to be patient for a long time. So how does Terraform support looks like? You can set it on a single instance. You can set it on the launch template. And it's not supported on the launch configuration. So there's a pull request to make that work, but it's not yet possible. So that's again also like a problem. And I think because of that, you can already see what the adoption of IMDS version 2 is. So it doesn't seem to be very high at the moment, but now AWS is really pushing it because everyone that's using Security Hub is now getting this alert or this kind of finding that they're not using IMDS version 2. So I think that will change soon because everyone is now kind of thinking about switching to IMDS version 2. So how do you prepare for a transition to IMDS version 2? First, you should update the AWS CLI on the instance. So only the latest version of the AWS CLI supports IMDS version 2. The same applies to the SDKs. Make sure that all your applications make use of the latest SDKs. Only then you will get support for the session-based approach. And also, you get insights into how many applications are still using the old version 1 endpoints, because there's a CloudWatch metric called metadata node token, and it basically records all the requests to the instance metadata service where no token is passed in the header to the instance metadata service. So if that metric goes down to 0 for a couple of days, you basically know that you fixed all the old usages of the IMDS version 1. And only then I recommend to upgrade and enforce version 2 of IMDS. So this will help you to ensure that there are no problems. Keep in mind that you also run things like deployments to check this out, because usually during deployments, lots of API calls are made. And so you also want to test those kind of events that might not occur in your 1 or 2 day frame where you look at the metrics. So make sure that you really invoke all those special scripts and stuff that run during a deployment. Great. If you have any questions, if you have any learnings or other pitfalls that you discover while you transition to IMDS version 2, let us know, let the community know. So we are really looking forward to hear from you. And also, if you have feedback to one of the videos, let us know. You can either send us a message on the community. You can also send us an email. You can also reach out on Twitter. So I show my details here in the video. So there are many ways for you to get in touch with us. You can also just reply to the emails we send you once a week, and we are happy to hear from you. So please feel free to reach out to us. So thank you very much for watching, and we will see us again in 1 week with another video. Bye.